Welcome to the AI Agent and Autonomy Model 6. And welcome to the first lesson. If Model 5 was about giving AI the hands it needs to touch real systems, this model is about giving AI a mind of its own to decide what it should do with those hands. That's a big jump. And if you ask me, this is where the course really starts to feel like science fiction. You spent the whole of last module building an MCP toolkit, an MCP server. What we're doing now is building the same thing that can pick up that toolkit and decide on its own what to do with it step by step and actually finish a job. Pick the tools it needs on its own and proceed with that. So let's talk about why this even matters now in the real world with real numbers, not just hype. Take Klarna, the payments company, for example. Now, let me tell you, a while back, they built an AI customer service agent, and by the third quarter of 2025, that single agent was, handling a workload of roughly 853 human employees, and it has saved the company about $60 million. That's not a chatbot answering just FAQs or just saying, would you like it? That's actually an agent resolving real customer problems end to end. Or look at JP Morgan. From what's been reported, they're running over 450 different AI agent use cases in production every single day across the bank. And here is one more stat that actually puts that trend in perspective. Gartner found that by the first quarter of 2026, 80% of enterprise applications that shipped or got updated included at least one AI agent baked in. Compare that to just 33% in 2024. So that's not a slow trend. That's an industry flipping over in about 2 years. So what actually makes something an agent instead of just a fancy chatbot? This is the core concept for today, and I want to keep it simple. A chatbot, what I mean is a normal chatbot waits for you to ask something, gives you an answer, and then stops. It has no memory of what it's trying to accomplish beyond that one question and answer. An agent is different. An agent has a given goal, not just a question. It keeps working, taking actions, checking its own progress, and adjusting until the goal is actually done, or until it decides it needs, help, external help or human help. So that's the pattern. There's a pattern that shows up again and again in agents design, and this even has a name that researchers gave it a few years back. It's called React. Okay, but re and act, a short for reasoning and acting. So what I mean is the agent doesn't just blot out an action. It reasons about the situation first in its own words, then decides on the next step, takes that action, observe what has happened, and then reasons back again on the new information. Think, act, observe, and then repeats the whole thing again. That loop is honestly the heartbeat of almost every serious agent system running in production today. So let me make that concrete for a second, because it's easy for this to feel abstract. So say you give an agent a goal like find out why this customer order is late, okay, and let them know. A chatbot will just guess an answer from general knowledge. However, an agent that is running that React loop will reason, I need to check the order status first. Then act by calling a tool that can look up the order. Then after, observe the results, and then maybe discover that it's stuck at the warehouse. And then reason again, okay, I need to check estimated ship dates since it's stuck. And then based on that, looks up, acts on it, observes the answer, and only then does it provide an actual accurate response to the customer. Every one of those steps is a full turn, through the same loop. So, think of it, in that loop, you actually see a few specific roles working together. There's a planner, which breaks down a big fuzzy goal into smaller doable steps. There's an executor which actually carries out each step, often by calling a tool like the ones we built, and maybe one from even the MCP toolkits that you built in the last model. And then there's reflection, which is the agent basically checking its own work and asking itself, did that actually work, or what should I do differently? If it didn't work. So, from my experience, that reflection piece is the one people underestimate the most, and it's actually the difference between an agent that quietly fails, or an agent that actually recovers and finishes the job. I don't know if you've noticed every time maybe a coding agent is thinking, you've seen it thinking and trying to fix errors and mistakes, over and over again. I want to be honest with you about something too. This is exciting, but it's genuinely hard to get right in production. A lot of enterprises have discovered that building an impressive agent demo is easy, but getting one to run reliably, safely, and under real governance is a completely different challenge. Right? So industry researchers have actually found that a huge share of agent projects that get them would never make it to real production, mostly because nobody thought about or thought hard enough about memory, about the tool reliability, about failure recovery, upfront. So if something goes wrong, how does the agent, recover itself? That's actually good news for you as an engineer, sitting through this course, because it means the engineer who understands these architectures properly, and then understands planning, execution, reflection, memory, and tool use, are going to be in serious, demand for a long time. Now, let me walk you through, what we're actually covering, in this module, lesson by lesson. So right now, we're going to go into agent memory systems, how agent remembers these things across conversations and tasks, and so they are not starting from zero every single time. Then we use tool use and function calling, where you connect your agents directly to the MCP toolkits that you built, in Module 5, so that they can act on real systems. After that, we'll look at chain of thought, pipelines, understanding when a simple sequence of steps is, smarter than a fully autonomous agent. Then we'll get hands-on with building autonomous workflows, where you construct an agent that can plan, execute, and recover from failure, and then delivers a finished result on its own. Then we close the module with multi-agent collaboration, where special agents work together as a team, rather than relying on one general purpose agent to do every single thing. Here's why this progression matters so much for the overall course mission. Remember, this course isn't just about learning to prompt AI faster. I'm sure you've seen that's not what it's about. It's about becoming the engineer who architects the AI native systems everyone else can depend upon. So agents are the layer where all of that comes together. Your understanding of models, your MCP tooling, your production instinct, all of it feed directly into building something that can operate with real autonomy. By the end of this module, here's exactly what you walk away with. You understand the core architectural patterns behind modern AI agents, including planning, tool use, and reflection. You understand how to give an agent memory so it behaves consistently across multiple interactions, just like he actually, is keeping an intelligent memory instead of forgetting everything instantly. You'll be able to connect an agent to real external tools using the MCP toolkit you already built. And you'll be able to build a genuinely autonomous workflow that can plan, execute, and recover from failure all on its own. And you understand how multiple agents can collaborate, with one another. So I'll be honest, this is one of the modules I get most excited to teach after laying the foundation of MCP, because this is exactly where things feel Stop feeling like just using a tool to, feeling like building that, robotic, futuristic, autonomous system. So get comfortable because we're going to build something with a mind of its own. Let's get started. See you in the next lesson.
Thanks for watching.